So let's do some examples that just have numbers in them. Now the first example that we're looking at with the square root of 24, it's a square root. So because it's a square root, the correct question we want to ask is what perfect square divides evenly into 24? So if we look at our square table, our powers table, 25 is already too big, so we don't care about 25, so we move up to the next one, which is 16. 16 doesn't divide evenly into 24, and so we move up to the next one, which is 9. 9 doesn't divide evenly into 24, so we move up to the next one, which is 4. 4 does divide evenly in, and how many times does 4 go in? It goes in 6 times. So I can break up square root of 24 as square root 4 times square root 6. So remember your steps were break it up, take the radical, clean it up. So now in this step, we're going to say, let's take the radical. I know the square root of 4 is 2. Square root of 6 doesn't simplify any further. Now in this case, there's not really a clean it up step. Clean it up is going to come in some of our more complicated situations. But our answer here is just simply 2 times the square root of 6. And we can write that as 2 root 6. Now for the second part of this example, the cube root of 24, we're looking for a cube root, and so we're looking for perfect cubes that divide evenly into 24. 27 is already too big, and so the next perfect cube is 8. And 8 does divide evenly in, so we can rewrite this as the cube root of 8 times the cube root of 3. Now the cube root of 8, we know the answer to that, that's 2. But cube root of 3, we can't simplify any further. And so that's really as good as we can get. Now it is important to use these 3 steps separately. Don't try to combine them. And I'll tell you why. You might think that you can do it in your head. But I will tell you from my decades plus of experience in teaching this class, and I teach this class pretty much every semester, the most errors I see is when people try to combine steps in this. And that's because you confuse your own brain. If we do the break it up step every time, and that's all we do is the first step, then we're going to have nothing but radicals in that step. In the next step after that, we're going to take the radical. So the only thing we're going to change is if we're taking the square root of a perfect square or the cube root of a perfect cube. If we change it, we know the radical goes away. And that's actually where I see the most errors happen. Is when people start combining steps, I see crazy things like turning this into 8 cube root 3. Or when they take the cube root of 8, I see cube root 8, or sorry, cube root 2, cube root 3, because in their head, they're taking the cube root of 8, but they're leaving the cube root symbol there. Those are the types of errors I see that are obviously wrong, but if we always follow the same steps, we're not going to make those kinds of errors. If we always follow the same steps that say, in my first step, everything's got a radical. In the next step, things that change no longer have a radical. And then in the third step, we're just going to clean it up if needed. All right? So on to the last example here, within example 3, we've got a fourth root. Fourth root of 32, so we're looking at our perfect powers of 4. 16 is a perfect power of 4, and so that's how we're going to break it up. We're going to have the fourth root of 16, and 16 times 2 would get me back to 32. And then the fourth root of 16 is 2. I'm left with fourth root of 2, and there's my answer.